So welcome you all in this video. Here we'll start the new topic which is called electrostatics. So let us see first the content of the electrostatics. There is an electrostatic field, their introduction, then some laws and definitions related to electrostatic, then the concept of capacitor and the capacitance, then the capacitors in series and parallel, their combinations, energy stored in the capacitors, charging and discharging of the capacitors, and time constant in RC circuits. So let us look at one by one topic. So first let us introduce ourselves to the electrostatic field. Now basically the electrostatics is the branch of physics that involves the study of electric charges at rest. So what it means, we have to study the charges which are at rest. So like in electromagnetism, charges are moving. Whenever the conductor which is placed in magnetic field, the charges are moving, the electrons are moving. So here we have to study the charges at rest. When we rub two bodies of different material against each other, an electric charge gets developed on them. When we rub two bodies of different material against each other, then electric charges will get developed around them. So there are several examples of this electrostatic field, like combing your hair, dry hairs with a comb. Then comb will be charged and it can attract small pieces of papers. Here we can see in this GIF image. So this comb is combing dry hairs with the help of this comb, and when you get it near to the small piece of papers, then it will get attracted. So this is what a simple example of the electrostatic field. Then we have some laws and definitions of electrostatics. First is the Coulomb's law. In first law state that the like charges repel each other and the unlike charges attract each other. So very basic, it is there in electromagnetism also. Second law, which is called inverse square law. The magnitude of the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between them. So here we can represent in mathematical form. So this force between these two charges, which is proportional to the product of the 2 point charges q1 and q2 and inversely proportional to the square of the distance between them, that is r square. And if we neglect the proportionality sign, then we have to insert a constant k, which depends on the nature of the medium. So this is called inverse square law. This expression for constant of proportionality is given by k is equal to 1 by 4 pi epsilon, where epsilon is the permittivity of the medium in charge in which the charge is placed, which is the permittivity, which is given by epsilon is equal to epsilon 0 into epsilon r, where epsilon 0 is the permittivity of free space and epsilon r is the permittivity of the medium. Some medium is there, then we have to use epsilon r. Therefore, by putting it in the above equation, we will get the force is equal to q1 q2 divided by 4 pi epsilon 0 epsilon r into r square, where the value of epsilon 0, that is the permittivity of free space, is given by 8.854 into 10 to the power minus 12, which is measured in farad per meter, that is F by m. The next term is the electric flux, like we have defined magnetic flux. So here the electric flux, which is defined as the number of line of force in any electric phase, the total number of, we can say, the lines of force in any electric field. So which is nothing but the electric flux, which is denoted by psi and measured in coulomb, right? So 1 coulomb of electric flux is defined as the flux that emanates from a positive charge of 1 coulomb. So we can write electric flux psi is equal to q coulombs. So these are equal. The next term is the electric line of force. Electric line of force are the imaginary lines which represent the stress distribution in electric field surrounding the charged body. So electric line of force which are liberated from a charge, a unit positive charge towards a negative charge. So this is like the electromagnet, the magnetic line of force which always liberates from the north pole and goes toward the south pole, which completes its part through the surrounding. So similar here, the positively charged and the negative charged particle. So this electric line of force will travel from the positive towards the negative charge, right? So this is called electric line of force. Then next one is the electric flux density. It is defined as the flux per unit area, which is measured in right angle to the direction of the flux. Very similar definition of magnetic flux density. It is denoted by capital D and measured in coulomb per meter square, C by m square. So we can write in mathematical form, which is the flux per unit area. So D is equal to psi by A, or we can also write D is equal to Q by A, because the charges which are equal to the fluxes. So Q is equal to psi. Next one is the electric field strength, which is defined as the mechanical force experienced by a unit positive charge when it is placed at any point in the electric field. So just like the magnetic field strength, we can define it. So there is a magnetic electric field, and in electric field we are placing one point, and how much the strength that point can feel. So we can define electric field strength. So that point, considering that point, we can define this definition. It is denoted by capital E and measured in Newton per Coulomb, N by P, or volt per meter, V by M. And mathematically it is given by E is equal to F by Q, measured in Newton per Coulomb. Now expression for electric field intensity. The intensity due to the charge Q at a distance R be equal to E. If a charge Q1 is placed at this point, then the force experienced by it is given by F is equal to E into Q1. So as per this basic definition, we can write this formula. But according to Coulomb's law, the force between Q and Q1 with distance R between them is given by F is equal to Q1 into Q divided by 4 pi epsilon 0 epsilon R square. Equating above two equation, we'll get this formula, and the final one capital E field strength is equal to Q by 4 pi epsilon 0 epsilon R into R square. So this is what the required expression for electric field intensity. Now the relation between the flux density and electric field intensity E. The flux density at any point is proportional to the intensity of electric field at that point. Therefore, D proportional to E. Flux density is proportional to field intensity. If you want to neglect the proportionality sign, then we have to put up the constant, which is the permittivity of the medium. So D is equal to epsilon E, or D is equal to epsilon 0 epsilon R into E, because epsilon is equal to epsilon 0 epsilon R. So this is the relation between flux density and field intensity. Then permittivity. It is defined as the ease with which a dielectric material acting as a medium which allows the electric flux to be established in it. So it will ease the electric flux to establish in that material, which is like the permeability, right? So absolute permittivity, it is defined as the ratio of electric flux density to the electric field strength in particular medium, denoted by epsilon and measured in farad per meter. So epsilon is equal to D by E. It is the ratio of electric flux density to the electric field intensity. Similarly, the permittivity of free space, it is the ratio of electric flux density in air or vacuum to the corresponding electric field strength in air or vacuum, denoted by epsilon 0 measured in the same unit farad per meter. So epsilon 0 is equal to D0 by E. And last, the relative permittivity. It is defined as the ratio of electric flux density in a dielectric medium to that produced in vacuum or free space by the same electric field strength. So epsilon r is equal to D by D0. Therefore, epsilon r is equal to epsilon E by epsilon 0 E. So E will get cancelled, and we can rearranging it. We can write epsilon is equal to epsilon 0 epsilon r. Again, it is measured in farad per meter. So that's all in this video. The remaining part we'll see in the next video. So thank you for watching it.